Hello, welcome to EcademicTube. Here on this platform, we are going to help you in online project reports, online lab reports, assignment guides, live sessions, and video solutions. You can reach to us through our WhatsApp number, that is this, and our company website, and through our email ID. So today we have a question of this strength of material. So here you can see in this question, what we have to calculate is, first let me tell you what we have to calculate is minimum diameter required for shaft BC. This is BC shaft. We have to calculate the minimum diameter and the diameter for bolt at A. This. Okay. These are the two things which we have to calculate. Now let's see what is given in this question. This mechanism which is in equilibrium. We have the applied load that is 16 kilonewton. This and the specification for the mechanism limit the shear stress in the steel is this steel the shear stress in this steel is 79 gigapascal, the shaft BC to 63 MPa, the shear stress in bolt is this. Okay, so we have the shear stress in BC also given. Shear stress in BC given is 63 MPa, and the shear stress in bolt is also given, that is 105 megapascal, and the vertical deflection at a point to joint D to a maximum value of this. Okay, so when you draw the displacement diagram of this CD, let me draw here. When we draw the displacement diagram of CD, this is C, this is D. Okay, when you draw the displacement diagram of CD, this is B. This deflection, that is delta D, is given to us. That is delta T is given to us. What? 25 mm. 25 mm. In starting, we have this P value, that is 16 kilonewton, and G of BC is given, that is 79 gigapascal. Now next, further moving, the assume that the bearing allow the shaft to rotate freely. Okay, this bearing is allowed the shaft to rotate freely, and we have some data also here. That is value of L. This is the length. A value and B value is also given. This is B value. This is A value. Okay. So now we have all the data. Now let's move forward to the question. So as we draw the displacement diagram, okay, this is the displacement diagram. Displacement diagram of shaft BC. This is the displacement diagram of shaft BC. Not BC, it is actually DC. Now, on this displacement diagram, you can calculate the value of phi, that is sine phi is equal to, this is delta D divided by B. Okay, and this will be, sine phi will be, delta D is given 25 mm divided by this B value is given, that is 205. So from here we can calculate the value of phi, that is 7 degree. Okay. Now let's draw the lever diagram, free body diagram of the lever DC. Free body diagram of lever DC. Okay. Because you see that this is the lever DC. When you pull this D downward, then you will get the free body diagram something like, let me draw for you, that is, this is C, this is D, and this is the force P, this is the load P which is acting. So the cause of torque will be due to this, the torque is force into perpendicular distance, right? Torque, what is torque? If you want to calculate the torque at point C, or you know that this steel shaft will going to rotate, because this will be like this, so this is going to rotate like this, so this is going to rotate with some torque T. Okay, and this T torque will be force into perpendicular distance, so this P into perpendicular distance. But what will be the perpendicular distance? Let's see. So by calculate, to know the value of that perpendicular distance, we have draw the free body diagram of the lever. That is, this is DC, this is P, and this distance is B, and this will be the perpendicular distance. Okay, this X, this is the perpendicular distance. We know that this value is phi, so again we can use cos phi. cos phi, we can write cos phi is equal to x divided by b. From this, we can write x is equal to b cos phi. So you can write the value of torque, that is torque is equal to p multiplied by this perpendicular distance, that is x, which is equal to p b cos phi. Also, we will going to use this torque value again and again. So let me write the actual data. What we can write, like value of p will be, value of p is 16 kilonewton. So 16 multiplied by 10 to the power 3 multiply by, that is b. B value is 205. So 205, it is in mm. So we will convert this in meter, and cos 7. So torque value T will be come out as 3255.55 Newton meter. This is the T value. This is, we will use it again and again. So I have just calculated it already here. Now you know the value of torque. Now write the torque equation using torque equation. Torque equation is T by J is equal to tau by R is equal to G by divided by L. Now we can calculate, we can write this equation in two ways. Like first we can take the first two term, T by J is equal to tau by R, and in second case we can use other two terms like T by J is equal to G phi by L, also we can use, right? So these are two ways, and we have to calculate the diameter of this shaft BC. So this is all about BC shaft. Okay, the all data we will take about for BC. Okay, so keep the note here that these all data we will take for BC. The G value, L value, J value, torque value. This is all for BC. Now let's by solving this first, and then we will going to solve this second part. So by doing first, you can write T at BC divided by what is the polar moment of inertia, pi by 32 d to the power 4, and this is BC. Keep remember this. This is tau of BC, and this R is dBC divided by 2. By rearranging this, we can write d to the power 3, or just write it like 16 T divided by pi tau BC whole to the power 1 by 3. If we are going to solve this, dBC is equal to 16 multiplied by 3255.55 divided by pi multiplied by what is d tau BC? Tau BC, this is 63 megapascal. 63 megapascal. This is Newton meter, okay? This is 63 megapascal. So 63 multiplied by 10 to the power 6 to convert the megapascal into pascal. Whole to the power 1 by 3. The dBc value from this equation comes out 0.06408 meter. This is the dBc value. Or we can write this data in mm also, 64.08 mm. This is the one value of BC diameter for shaft BC. Now moving to the second way, if I calculate the diameter using this equation. So this is again T by J, this is pi by 32 d to the power 4 is equal to G. G we know G data, right? G and phi. Phi is in degree. Remember, this phi is in degree. We have to calculate this degree in radian. So remember, we have to convert this degree in radian by multiply by pi by 180, and this is L value. Okay, from this equation we can write D is equal to, from this equation we can write D is equal to 32 T L divided by G phi G phi into pi whole to the power 1 by 4. Okay, now D will be, so this dBc will be 32 multiplied by, again torque value is 3255.55 multiplied by length. Length is given 1.1. This is 1100 mm. So we have convert this mm into meter, 1.1 meter divided by G value is, what is G value? G value, let's see. G value is 79 gigapascal. Okay, G value is 79 gigapascal. 5 we know. Okay, 79 gigapascal. 79 multiply by 10 to the power 9 multiply by this 7 degree. So we will convert this degree into radian by multiply by pi by 180 multiply by pi already it is there whole to the power 1 by 4. By solving this equation we get the value of diameter for shaft BC will be 0.04409 meter or DVC will be 44.09 mm. So you have two values. 44, you have two values. This 44.09 mm and 64.08 mm. Which value you will use? You know which value you have to use. You will consider the maximum diameter by because it will satisfy both maximum shear and angle of twist criteria. Okay, so the maximum value of DBC will be 64.08 mm. This is the answer of part A. Okay. Why we have to calculate this? Why we have to consider the maximum value? Because it will satisfy both maximum shear and angle of twist criteria. Done. Now let's move to the second part, which is we have to calculate the diameter of bolt, right? At A. This is the second part. Okay. For this, we are going to check our diagram how we can calculate this. Let's see. We have to calculate the diameter at this. Okay. So, but torque in this will be cause a force in this. Okay. This torque, the torque at bolt, we have data that is torque at bolt given. So this torque will be equal to force divided by area of bolt. Force divided by area of bolt. What is the force? What will be the force here? Force we can calculate by this torque. How? This force will be torque divided by area. Torque divided by not area, torque into A. The force will be this is A, this is torque. So you know the torque in this, you know the torque in this, right? This at this point you know the torque and you know this distance. So this is perpendicular distance. You can write torque is equal to force into A. By this equation you can calculate the force. Okay, you can calculate the force and by using this equation you can calculate the area of bolt. That is very simple. Let's try. So what was the equation? Torque equal to force into A. So by from this equation you can write force equal to torque divided by A, and this torque will be 3255.55 divided by value of A is it is 0.11. Okay, that is 110 mm. So we have converted it in meter. 0.11 meter. 29595.92 Newton. This is the force. The second equation was torque on bolt will be force divided by area of bolt, right? This torque in bolt will be the shear stress in bolt is given, that is 105 megapascal. So we will convert this. We are not going to convert this. Actually, what happened when we use this stress is equal to force upon area, and if you write the area in square you will automatically get the stress value in megapascal. So if you are using the stress value in megapascal you will get the area in square. You can say that diameter will be in so I am not going to multiply it by 10 to the power 6. It will automatically give me the diameter in units. So 105 is equal to 29595. So this will be 29595.92 divided by area will be pi by 4 d bolt square. By solving this equation, you will get the diameter of bolt will be 18.944 directly in mm. So this is your final answer. So in the question, we have to calculate two values, diameter of shaft BC and diameter of bolt. So these are the two answers. I hope you got the exact method for this question to solve. Thank you.